In this video, I'll be showing you how to use MongoDB in Python. Specifically, I'll be showing you how to set up a remote MongoDB database using MongoDB Atlas. I'll show you how to connect to that database in Python. I'll explain the MongoDB document model, and I'll demonstrate the CRUD operations like creating, reading, updating, and deleting. After that, I'll briefly discuss relationships using document embedding and foreign keys, and that is what I will talk about in this video. This tutorial is designed for beginners. No advanced knowledge of Python is required. And with that said, let's go ahead and get into it. So let's begin here by talking about what MongoDB is. MongoDB is a NoSQL or NoSQL document-oriented database that is extremely fast and easy to use. It's personally one of my favorite databases, and I especially love to use it for my hobby projects that I want to get up and running as fast as possible. MongoDB provides a full suite of developer-friendly tools like MongoDB Compass, MongoDB Shell, and a great VS Code extension. Generally speaking, it's one of the simplest databases to learn and has a very low barrier to entry. It's also highly scalable and performant and can be used in enterprise-grade applications. So all of these facts are why I was super happy to have MongoDB actually sponsor this video and team up with them to create this fully guided tutorial, as well as some additional ones that will be posted on the channel shortly. Now, MongoDB is free to use with a basic configuration and can be hosted in the cloud or locally. However, since MongoDB has sponsored this video, they're going to provide all of you with an additional $25 in free Atlas credits, which you can redeem by clicking the link in the description and using the code MKT-TIM. Now that we have a general introduction to MongoDB, let's create and connect to our first database. So as I mentioned, the first step for us in this video is to create a remote MongoDB database. We're going to host this using something called MongoDB Atlas, which is completely free, and you can find the link to start doing that from the description. Now, as a reminder, if you do want some free credit for MongoDB, maybe you want to play around with it after this tutorial, then use the code MKTTIM that will be in the description as well as up on the screen. Anyways, the page that I'm on right here is what's linked in the description. Gives you some information about using MongoDB in Python, actually pretty helpful, but I'll walk you through all of these steps anyways. So what we need to do here is either sign in or click on try for free, depending on if you have an account or not. I'm going to walk you through the setup steps from a brand new account. Let's do that now. So I've just created a new MongoDB account here. I just signed in with Google. Of course, you can sign in however you'd like. And I'm just going to go through the privacy policy and all of this type of stuff and kind of walk you through what we need to do here to get our first cluster and database set up. So you'll be brought to a page like this that kind of asks you some information. So I'm going to say I'm going to learn MongoDB. I'm curious if they have kind of education in here. We'll just go with other for now. I'll say education. What's your preferred language? And then we'll go with Python. Now, once we fill that out, we're going to be brought to a page like this. We want to select the free plan for now, although, of course, if you want a dedicated one, then you can go for that. And I'm going to click on Create. And for now, we're going to make sure that it's shared. That's what's free. And we're just going to go through a few configuration options here. So anything that doesn't have the little, I guess, dollar bill beside it is free. So depending on what you're closest to, select your region. In my case, I am probably going to be US East because I'm kind of in Toronto region and they don't have a Canadian one right here. That's fine. And then for your cloud provider, I'll just go with AWS. It doesn't really matter. All this type of stuff, you don't really need to change, and you actually can't really change most of it because we're just going with the free plan here. But for the cluster name, you can name this whatever you want. In this case, I'm going to name it tutorial. And as it says here, you can't change this once it's named. So just give it a name that you're going to like and want to keep. But again, this is for demo purposes, so not a huge deal. Okay, so I'm going to click on create cluster here. That's going to take a second. But first I need to enter a username and password that I can use to sign into my cluster. So obviously don't forget what this information is. I'm going to go with Tech with Tim, and then I will type out a password here that I'm not going to tell you and create my user. Okay, my user has now been created. And that's going to ask where we want to connect from. So local environment or cloud environment. In this case, we're going to connect from our local environment. And to be able to do that, we need to add our IP address to the allowed IP address kind of access list. So they actually make it really easy here. You can just click on this button. I'm going to blur this out because obviously I don't want to leak my IP address, but I'm going to add this to this list. So I'm going to say add my current IP address. That is now added. And then we can click finish and close, and go back to databases. Now that we are here, we just have to wait for the cluster to be created. Once it is, I will be right back and walk you through the next steps. So my cluster has now been created. You can see tutorial right here, and I can click on it to view the overview page. And I just want to mention that what a cluster is kind of an abstraction on top of a database. Not exactly, but it is a higher level than a database. Databases would be inside of a cluster. And in this case, the type of cluster I have is a replica set with 3 nodes. Now, what that means is that I actually have redundancy here because I have 3 servers that are running my database. So my database is going to exist in 3 different places, and this is going to provide better scalability as well as redundancy, right? In case any of the servers go down or in case we lose some data, we'll have that backed up in multiple places. Again, I don't want to get into this too much. It's a bit more advanced than what I want to talk about in this tutorial, but I just figured I'd mention a cluster. Again, it's kind of on top of a database, provides scalability as well as redundancy, and a few other things. For now, though, let's click into tutorial, and you can see there's all kinds of stuff that we can have a look at here, and we can click on connect. Now, connect is what I want to go to because we need to grab our connection string and figure out how to connect here. So we can connect our application, we can connect using MongoDB Compass, which is a developer tool, and we can use the MongoDB shell, same thing, that is a developer tool. For now, let's go with connect your application, and we're going to select Python here. And we'll go version, I guess 3.11 or later. Shouldn't actually make a big difference for the connection string here. Okay, so now that we've done that, it's telling us that this is the string we're going to use to connect to our cluster and to connect to our database. So we can copy this and we'll bring this into a Python file. Now, I just want to mention quickly that there is a program here called Mongo CLI, so the Mongo command line interface. You can do everything that I just did from the CLI, but it's easier to go through the graphical user interface setup if you're not familiar with this. So if you care to, you can download the CLI. I'll leave a link to this in the description. And again, you can create a cluster, create a database, collections, all that type of stuff from the command line. You don't need to do it from the graphical user interface. Anyways, we've pretty much done what we need here for setting up our remote database. So let's go into Visual Studio Code, which is the editor I'm going to use for this video. And let's just paste our connection string right here into a Python file. We'll deal with it in a minute, but we just want to have access to that for later on. So now that we're here in Visual Studio Code, I'm just going to open up my terminal here and start installing some of the dependencies that we need for this project. The first thing that we're going to need is what's known as the PyMongo module in Python, and this is going to allow us to easily interact with our database. So we just want to go into a terminal or a command prompt and type the following command, pip install, and then this is going to be PyMongo, and inside of square brackets, you're going to put srv like that. So try this command. I should already have this installed, so it should happen pretty quickly. And then once we do that, we're going to install one more module as well. So the next module is going to be python-.env. This is going to allow us to access an environment variable file where we're going to store our credentials for signing into MongoDB. Okay, so those are the 2 pip commands that we need to run. If for some reason those commands don't work for you, you can try the command pip3. You can also try python-m pip install or python3-m pip install depending on your operating system. Try all of those, and if none of those work, I'll leave 2 videos on the screen and linked in the description that show you how to fix this command. Okay, now that we have that installed though, we're just going to set up VS Code to be better for working with MongoDB. So there's actually an extension in VS Code if you go to the extensions pane here for MongoDB. So if you just type in MongoDB, you'll see the extension by the verified creator here or author, and you can install this. I already have it installed. Now this extension provides a bunch of awesome features where we're able to navigate our data, actually view it here and visualize it. We can go into a playground, mess around with some queries. We can do a bunch of other stuff like document editing. Very useful and definitely something you want if you're going to be working with MongoDB. Once you install this, you probably need to refresh VS Code. Then you'll see a little button here for the extension where you can actually connect to your cluster, which we'll do in a second, as well as go to the playground. Okay, so now that we've done all of that, let's actually connect because we want to start writing some code here for MongoDB. So for now, I'm just going to say my connection_string is equal to, and then I'm just going to put this in a string. And when I save, hopefully it's going to put that on a new line. Okay, it's not. So let me just separate this a bit just so we're able to read it. And I'll go with a triple quoted string here, just to make that a little bit easier to see. Okay, so that's my connection string, but you'll see here that we need a password. So what I'm going to do is make an environment variable file here. So just follow along. I'm going to make a new file called .env. make sure this file is in the same directory as where your Python file is. And inside of here, we just want to make a variable. I'm going to call this MongoDB underscore PWD, standing for password. And I'm going to make this equal to whatever the password is. Now, of course, I don't want to show you what this password is, so I won't type it in right now, but place your password in a .env file that has MongoDB underscore PWD equal to, and then whatever the password is in a string. Once you've done that, we can go to main.py, and we're going to use that python.env module to load that environment variable file and get access to our password without leaking it directly inside of the code. So to do this, I'm going to say from, and this is going to be .env, import, and we're going to import load.env. We're also going to import find.env. So the first thing we'll do here is say load underscore .env. We're then going to put inside of here find.env, and this is kind of a shortcut that's just going to load the environment variable file for you, so you don't have to manually define the path and all of that. Now, before we do that, we'll import a few other things. We're going to import OS. We're going to import pprint, which stands for pretty printer. We'll have a look at that in a minute. And then we're going to say from pymongo, and we are going to import the Mongo client, which we'll use to make a connection. Okay, now that we've done that, let's grab the password from our environment variable. The way we can do that is say the password is equal to os.environ.get. And then we're going to put the corresponding name that we had in our env file. So it's going to be MongoDB underscore PWD. That will then give us the password that's stored inside of here. All right, so now that we've done that, we're just going to change this string here to an F string, only available in Python 3.6 and above, by the way. And I'm going to put my curly braces and insert my password into the connection string. Now that we have that, we can actually connect. So I'm going to say my client is equal to the Mongo client, and then I'm going to pass the connection string like that. So at this point, we're pretty much ready to test this code out and see if it's working. However, I do need to make a quick fix here. I realize that this says my first database. Now that's just the default option that it gives you for MongoDB. We don't have this database created yet. So if we try to connect to it, there's going to be an error. So I'm just going to remove that. And I'm actually going to move all of this up onto the same line just because I think it's going to give us an error if it's not all on the same line. So that means we can kind of remove the triple quoted string here and make it a single quoted string. And now that should be all good. So let's test this code out by just running it. And if we don't get any errors here, that's good. That means that we were able to connect and it looks like everything's happening fine. We're not getting any errors. Great. Now that we've done that, I want to show you a graphical user interface tool called MongoDB Compass that allows you to actually visualize the database and is going to be really helpful to us. Now, again, we can do this from the VS Code extension, but Compass will work even if you're not in VS Code, so I figured I'd show it to you. This is what the application looks like. However, if you want to download it, I will leave a link. So you have Compass right here. Another way to get to kind of the download of MongoDB Compass is to go to your cluster, click on Connect, click down here where it says Compass, and then select either I don't have Compass or I do. And you're going to have to go here anyways, because what we want to copy is the connection string right here. So copy the connection string, then open MongoDB Compass. So we're going to copy that here. We're going to go to Compass. I'm assuming at this point you would have ran through the installer if you're going to download this, and you should be able to simply paste this in. So I'm going to say, are you sure you want to edit your connection string? Yes, I would like to edit it. I'm going to paste in this connection. I'm going to write out my password. Editors, please blur this. And now that we have that, we can click on Connect. All right, so I've just connected here to the database. If this doesn't work, again, make sure your IP address is in that access list. You can get there by clicking on Network Access from the side panel here, and then add your IP address. Now, though, we see that we have two databases, admin and local. So we can create a database manually here, or we can do one from code, or additionally, we can do one from the CLI tool. As you can probably tell, MongoDB has a ton of pieces of software to help developers out and make it easier than doing it all manually from code. So why don't we just make a database? While we're here, we can call it test, and then we're going to create something known as a collection, which I'll discuss in a second, and we'll call that test as well. Okay, so let's create that. It takes a second. We now see that we have tests, and if I click in here, we have a collection, and inside of here, we'd be able to view all of our documents. Again, I'm going to discuss what that means. All right, so now that we've done that, let's simply see if we can view some information about our database from our code, and then I will talk to you about the MongoDB document model and kind of how it's different than SQL. So for now, what we can do is say that our databases, so DBS, is equal to, and then we can use our client, and we can use the method here, list database, and I think it's just going to be database names like that. So for now, let's just print this out. We'll print out the DBS and let's see what we get. And notice here we have 3 databases: test, admin, and local. Now, if we want to access a database, it's pretty easy to do this. I can say my test DB is equal to, and then this is going to be the client dot, and you just put the name of the database. So I can do test. Now you also, I believe, can access it like this, so using kind of the dictionary or key syntax, but usually I prefer just to type it out like this. Okay, so client.test, and what we can do is list all of the collections inside of this database, and the way we do that is say collections is equal to, and then this would be the test underscore database, and then not get, but this is going to be list underscore collection names like that, and then of course I can print out collections. So let's run that, and let's see what collections we have, and notice we have one collection, test, which is the one that we just created. Okay, now that we've talked about that, let me just hop over, I guess, to another screen and discuss the document model, and then we'll come back here and look at the CRUD operations. So now that we've created our first database, let's briefly discuss the differences between MongoDB and a traditional database. So most databases are known as Relational Database Management Systems, or RDBMS for short. And they store structured data in something called tables. Now, they usually use a language called SQL, or SQL, standing for Structured Query Language, to perform modifications to data and enforce a strict set of rules for your data. There's plenty of merit to traditional SQL databases, but for us Python users, MongoDB, being a NoSQL database, can be much more flexible and easier to work with. So a NoSQL database, like MongoDB, actually stores unstructured data, and it's typically in JSON format. Now, this allows us as developers to perform frequent updates and changes to the structure of our data, and often use more familiar types and not be kind of restricted by some of the bounds of a SQL database. Now, NoSQL databases also can typically perform faster queries and scale out more easily, just based on the way that they're designed. So now that we understand some of the core differences, let's talk about MongoDB and something called the document model. So MongoDB has databases. A database is made up of collections, and a collection is made up of documents. Now, the documents store all of your data. That data is categorized into collections, and the collections make up a single database. So to give you a concrete example, if you were building a database for a library, you may have the following collections: a book, a person, maybe a rental for like taking out a book, and within each of those collections, you would have documents which actually store the data related to the collection. So in the book collection, you may have a document that stores an author, title, publish date, maybe the number of copies available, and a bunch of other data as well if you wanted to. And then continuing here, the data in your documents is stored in a field value pair. So it's kind of just like a dictionary in Python. You have a field, that field has a value, that's what you're placing inside of your documents. Now, this means you can store things like arrays, subdocuments, and any other valid BSON type. So internally, MongoDB actually uses something called BSON. It's similar to JSON, but it does have some minor differences. And I'll put up on the screen here the documentation. And as I scroll through, you can kind of see some of the types that are available to us here in BSON. So with that said, that's really all you need to know about MongoDB to get started. So let's start creating some data and learning MongoDB. All right, so hopefully that was helpful and gave you some insight into how MongoDB works. Also gave you some of that core terminology. Now that we understand that, let's look at a quick example of inserting a document. So actually creating a document, inserting it into one of our collections. Again, the collections you can kind of think of as tables, right? Or a place where we are collecting information, collecting different documents. So here what I'm going to write is just a function just to keep everything nice and neat. I'm going to say insert, and then this will be the test underscore document. And then what we want is to get access to the test collection from our test database. So I'm going to say my collection is equal to my test database, so test underscore DB, and then to access a collection, just like we access the databases, we use the dot notation, and I put the name of the collection, and we know we have one called test. So testdb.test, now I'm accessing a collection, and once I have a collection, it's very easy to insert a document into it. So we're gonna make a test document here, and really the documents, we're just gonna use Python dictionaries to represent them. As I talked about, they're very similar to JSON. Internally, MongoDB uses something called BSON, but what will happen is any types that we have here will automatically be converted into the correct MongoDB types. So we don't have to worry about specifying something's a string or an int or a float. It just automatically gets converted into whatever type MongoDB can handle, if it can handle the specific type that we have. So for now, let's do something really simple, like just have a name, and then we can have maybe a type along with this, and the type we can just do something like test. Okay, so from here, we are now able to insert this document. And the way we do that is we say collection dot, and then we're going to use the method insert1, and we just pass the document that we want to insert. So we do test document like that. Now, one thing we may want to access with this document is its ID. So every single document in our collection is going to have a unique ID. You can kind of think of this similarly to the primary key that you might have in a SQL database, and that is the unique identifier of this document. So if we wanted to access that, so inserted underscore ID, we could say inserted ID is equal to this dot inserted ID, and that simply gives us the ID of the document that was just inserted into the collection. So what I'll do is just print insert ID just so we can verify that this is working and we're getting some output. And now let's simply call this function. So insert test document like that. Let's save. Let's run our code. And let's see what we get. And notice we get this, this string here telling us what the insert ID was. Now, this ID is what's known as a BSON object ID. This is actually a specific type. I'll show you how we kind of work with those in a few minutes, but just keep that in mind. It's kind of a unique type. It's not just an integer. All right, so now that we've done that, let's go back to Compass here and let's refresh. Where is refresh? And notice that I have a document now inserted. It automatically has this underscore ID field. Again, that's the unique identifier here. And then we have any of the information that we added, like name and type. Great, so super easy, simplest, possible way to insert something into a database. So now that we've done that, let's have a look at more insert operations and actually creating a database or a collection here from code. So to make a new database is super simple, and same with collections and documents and all of that. But I can do something like, let's go with production, and we'll just call this database production just to have, kind of a unique name as opposed to test. So I'm going to say production is equal to client.production. Now, when I do this, I try to access a database that doesn't currently exist. MongoDB is automatically going to make that database for me. So very straightforward. We now have that. And then after we do that, we can create a collection. And in this case, I'm going to call it the person collection. So I'm going to use my production database and access the person collection. And again, similarly to here, since person collection doesn't exist, it will automatically be created. Then what we need to do is insert a document, because if we don't insert anything, it actually won't make this. We need to insert a document first. So let's write a function here and say define create underscore documents, and let's actually see how we can create multiple documents at the same time, because I already showed you how to insert one. Okay, so we're going to say first underscore names, and in fact, rather than me typing this all out, let me just copy it in and save us a bit of time. So we're going to say first names is equal to this, last names equal to this, and ages are equal to these, just having some corresponding values. All of these are the same length. Now we're going to loop through all of these, create a document of them, and then simply add that document. So what I can do here is say for, and we can say first underscore name, last underscore name, age in zip, and we're going to zip all of these. So first names, last names, and age. When you zip, it's just going to give us all of these items at the corresponding indices in a tuple, kind of a useful function in Python if you haven't seen that before. And then we can say our document is equal to, and we can go with first underscore name is equal to first name, last name is last name, and age is age. Thank you very much, autocomplete. And then we can do something as simple as person collection.insert1, and we can insert the document. Now that's one way that we can insert multiple documents. We can just loop through, but a more efficient way would be to do the following. So I can create a list of documents by saying docs.append, and then appending my individual documents. And then rather than inserting them one at a time, we can simply use the insert many. So I can say insert many, I can pass a list of all of the documents I want to insert, and then that'll do it for me. So in fact, let's do that, and let's call create documents here. Let's just test this out and see if it works. Okay, so I'm going to run the code, give that a second, and this is local variable age reference before assignment. Sorry, need to change that to be ages, not age. Let's rerun, and there we are. Okay, so now if we want to verify that worked, we can go to Compass. We can have a refresh here. We now see we have a new database called production. We have a person collection, and we have a few people that we're now inserted inside of here because of the code that we wrote. All right, Easy enough, that is how you insert documents in. And I just want to show you here the comparison to if we were to write the SQL queries to do this, just so you get a real idea of how flexible and easy this is compared to working with SQL databases. So if we wanted to do this in SQL, I'm just going to paste this in here. We would need to write the following first. So this would be, I guess, the query or the creation string that we need to write to create the table person, which is kind of the document that we just created, right? We had our person collection, and really I probably should have just called that person, but that's fine. Anyways, we would have had to create this table in our SQL database, and then if we want to insert something into the database, we would have had to write this string right here. So not overly complicated, but definitely not as intuitive and simple as this, and something I prefer to stay away from if I can, writing complex SQL queries. Anyways, there you go. That's the comparison in terms of the SQL queries. Now let's move on and look for how we can query documents, because obviously we want to be able to look through our database and find some different elements. So what I'm going to do now is write a series of queries that we may want to perform on our database, or I guess in this case, our collection, to find some different documents. I'll kind of go from easy to more difficult, and I will mention that if you're interested in more advanced queries, then stay tuned for the next video in this series where that's really what I'll be focused on. For now, though, let's write a function that just says find all people, and we'll see how we can just get all of the documents that are in our collection. Now, to do this is pretty straightforward. I'm just going to say people is equal to, and then this is going to be the person collection, and not .findAll, but .find. Now, .find allows you to insert a query object, which is different properties that you're trying to match with when you're looking for elements, or looking for documents, sorry. In this case, if you leave this empty, it's just going to find all of the people or all of the documents in the collection. So what I can do now is say for person in people, and I can loop through this. And I'm just going to use something here called the pretty printer to print this out. And the way we're going to do that is we're going to say our printer is equal to pprint.prettyprinter. Now recall that I imported pprint up here. That's why I'm able to do this. And rather than using the standard print statement, I'm going to say printer.pprint and print out person, just because it's going to give us a nicer formatted output. Now that we've done that, we can call this function, so find all people, and test this out and see if it works. And I'm just looking through the rest of the code to make sure we haven't made any mistakes up there, and it looks good to me. Okay, so let's run this, and notice now that when I print this out, I get some better formatted output than our traditional print statement, and you can see I have all of the documents that are in my person collection that we just inserted. I get them here, and I can treat these as Python dictionaries. I have key access, and everything you would know about a Python dictionary applies here. Great. Now, one thing to note here with people, if I try to print out people, you're going to see that we get kind of a strange result here. We get a PyMongo cursor. Now, the cursor is something that you can iterate over. So you can't directly access or index, say, the cursor. You can iterate over it in this way. Or if you just want to get all of the elements from it and store them somewhere, you could print out, say, the list of the cursor. So if I do this here, you see when I print that out, I get a list of all of the different people. So I just kind of wanted to show that to you. There is, a unique way of dealing with the PyMongo cursor. Really, it's going to act as a generator or an iterator, but I imagine many of you are probably not familiar with that, so that's fine. Okay, so now that we have find all people, I'll show you again that the equivalent SQL query to do this would have been select asterisk from person. Not overly complicated, but this seems a bit more intuitive to me. The next thing I'll show you how to do is look for a specific document based on a field value. So maybe we want to search for a first name equal to, say, Tim or something like that, right? So to do that, let's write a function. I'll call this find Tim because I want to find myself in our database. And let's see how we do that. I'm going to say Tim is equal to person collection. Rather than find, I'm going to do find one. And then inside of here, I'm going to put the field as well as the value, or the fields and the values that I want to access from my collection. So in this case, I'm going to say first name, and I want the value of first name to be Tim for anything that I select here. So I'm saying I want to find one, and the first document that I find that matches this criteria where first name is equivalent to Tim will be returned to me. And then again, I can use my printer and pprint this out and have a look at it. So let's call find Tim. Let's run this code, and notice here that I get the document associated with Tim. Now, usually you want to search for documents using their ID. Sometimes you don't know the ID, like in this case, I don't know what the ID is. So instead I have to use a field. Now I could also specify multiple fields here and do something like last name and then go with my last name. And assuming this matches the document, I would get it. But these all have to match. It's not like an either or. It's any field you specify here, the value needs to match exactly for this to be returned to you. Now you can do the same thing in find, just the regular find command, and then it will return all of the documents that match that criteria. For now, though, we'll go back to what I had before. Okay, so now that we've done that, let's have a look at how we could do something maybe a bit more advanced. I will also, again, show you the equivalent SQL query for this would be something like this. Select star from person where first name is equal to Tim. Okay, let's get rid of that. Next, though, let's write something that can count all of the people that we have. So we'll call this count all people, and inside of here, we can say the count is equal to, and then there's a few different ways to do this, but I'm going to say person collection dot count underscore documents like this, and then I can pass an optional filter here, which again is going to be something similar to this, which will only count documents that match the filter. Now, if I leave the filter empty, then of course it's going to count all of the documents because everything will match an empty filter. Anyways, though, if I'd like now, I can print something like number of people and then count. And if we call this count all people and run the code, you'll see that we get the count. So there's 6 people or 6 documents really in our collection. Okay, so that is one way to count. Another way to count is to do the following. We could say count is equal to person collection dot find, and then we can say dot count. And dot count will essentially give us the length or the number of elements that were returned by this find. So you don't have to count all of the elements. In this case, you can count all of the ones returned by the find. But we should see that we get the same result here as 6 when we run this, and yes, we do. Okay, it's actually telling us that this is deprecated, so maybe we should use what I did before, count documents, but still count can be useful in some context. Okay, now that we have done that, let's write something that can find a person by their ID. Now, this seems trivial because I've showed you how to search by a field name already, but we actually need to do something specific here for this to work. So let's write a function. This is going to be get person by underscore ID. And inside of here, let's take a person underscore ID. Okay, so now we're going to say from, and this is going to be bson dot object ID import, and then object ID like that. Now, bson, I believe, is built into Python, so I don't think you actually need to install that. If for some reason that doesn't work, then you can do pip install bson, although I imagine that's going to work for all of you. And from here, we will now create an ID that is equal to the object ID. That wasn't exactly what I meant to describe, but you'll see what I mean. So I'm going to say ID is equal to object ID person ID. I'm just putting an underscore here so I don't shadow the built-in ID function in Python. And this is what I was talking about previously, is that our IDs, when they get returned to us or when we kind of punch them in here, they're going to be strings in Python, but we need them to be this special object, which is object ID. Otherwise, they're not going to work when we try to search for them in our MongoDB database. So keep that in mind. It's kind of the one quirky thing. You need to convert all of your IDs to object ID objects from bson. Okay, so now that we've done that, I'm going to say person is equal to the person collection, and then we're going to say dot find one. And now we're going to query by the underscore ID, and we're going to pass, well, the underscore ID, which is the bson object. Then we can say printer dot pprint, and we can print out person, and we can call this function. So let's say get person by ID. We just need to grab an ID, so let's grab that from MongoDB Compass. Let's find the ID here of, say, Sarah. So let's copy that in and paste that here. Notice we have a string. It will then be converted for us. You could put this import statement somewhere else. I'm just putting it in the function so it's self-contained. And now when I run, you will see we actually got an error. No built-in module pprint. Oh, sorry, this is printer.pprint. Okay, silly mistake. Let's run that again. And notice here that I get the object I was looking for. I get Sarah accessing by ID. Wonderful. Okay, now that we've done that again, let me just show you the SQL query, just so you guys get an idea of what you would write equivalently. So if I wanted to access a person by their ID, I would write something like this. And from the previous one, because I didn't show it to you, we would write something like this: select count asterisk from person. Again, less intuitive, and if you don't know SQL, probably hard for you to come up with without doing, a few Google searches and stuff like that. Okay, we have done that. The last thing that I will show you is how to get kind of a range of something, how to do a bit of a more advanced query. And of course, you can do much more advanced than what I'm going to show you here. But for now, let's see how we can get people that are within a specific age range. So I'm going to say define get age range, I'm going to take in my min age and my max age. I'm going to search for only people in my collection that are within this age range. Now we can pick inclusively or exclusively. I think here we'll go inclusively. So let's actually build out our query string or our query object here. And I'm going to use kind of an operator from MongoDB, which is called $and. Now there's a ton of other operators in MongoDB. Again, in the next video, I will show you a ton of them. You can also reference the MongoDB documentation. But what we can do is query multiple things using the and if all of the queries that we write here are true or they match, then it will return the object for us. So similar to kind of an and in logic, right? In Python when you would use the and keyword. Okay, so we have and, we're going to pass a list here, and then inside of the list, we're going to pass different queries. So the first query that I want to do is related to the age. Well, the next one will be age as well. So I'm going to say age, and then I'm going to pass another object inside of here, and I'm going to use an operator, and this operator is going to be GTE, standing for greater than or equal to. Now we also have greater than, we have less than, we have less than or equal to, we have equal to, we have a bunch of them. Again, I will show some more to you in a later video. Now though, we have GTE, and we want to say that we want the age to be greater than or equal to the min age. So you kind of got to get used to the syntax. We're saying this is the field, and then this is the query we want to apply on the field. We don't want to check for exact equality. We want to see if the minimum age, if the age is greater than or equal to the minimum age that we place here. Okay, now let's copy this because it'll be very similar for the next one. We're going to say age. We're going to change this to LTE, so less than or equal to. We're going to make this max age, and now this query, when we use it inside of our find, will return everyone in this range. So I'm going to say people is equal to person collection.find. We're going to query, and then we can also pass something here like .sort. And when we do this, I can sort by age, and then I can grab the sorted results here. So let's now have a look at this. We're going to say for person in people, and we'll say printer.pprint. And we will print our person out. I can then call the function, so get age range, and let's look for people that I guess are within the age range of what ages do we actually have. I guess we could do something like maybe 20 and 35 or something, and that'll give us a few results. Okay, so let's do 20 and 35. Let's run our code. And we got an issue here, unhashable type dictionary. My apologies, guys. I have an accidental secondary kind of dictionary surrounding the and. So let's save that. Hopefully that format's better for us. Okay, that's better. Sorry, I had another set of curly braces that I really didn't need, and that's better. Okay, so let's run this and see. And there we go. We get all of our results here, and we can see that they're within the age range, right? So we have 21, 23, and 34 sorted by age in ascending order. Wonderful. Now that we have done that, again, we'll show you the SQL query. So let's have a look at this SQL query. This is what it would be. I actually pasted as a comment this time. Select asterisk some person where age is greater than min age and age less than max age. Great. Okay, I lied. I'm actually going to do one more find query here. Then we'll look at updating, deleting, and some relationships as well. Okay, so the next thing I'll do is show you how we can project specific columns, because sometimes when you are querying documents, you don't care about all of the information, you only want to get some of it. So I'm going to say project columns, and inside of here, I'm going to create a dictionary here containing the columns that I would like to have in my result. So I'm going to say _ID, and I'm going to put 0. Now that indicates that I don't want to have the ID in my result, so don't give me the ID field of any of my documents. I'm then going to say my first _name. This is going to be 1, which means yes, I would like to get my first name. And then I will put my last _name, and I will put that as a 1 as well, indicating that I want the last name. So now what I can do is say people is equal to person collection.find. I can pass my query object here, and I can also pass my columns. Now, I don't need to pass this as a keyword argument. I can pass it positionally. And when I do that, it's now going to do a projection, which just means it's only going to give me the columns I specified, right? So let's just copy what we had here for printing this out. Okay, and then let's call this, so project columns. Let's run our code, and let's see what we get down here. And notice that we get our first name and last name. We do not get the age, and we do not get the ID because we did not specify that we want those. All right, so that is it for querying. That's really all you need to know for basic querying. That should get you by if you're doing kind of a beginner or hobby project. Now, though, we want to look at how we actually update a existing document in our collection. So let's write out a function here, and let's call this update, and let's go person, and then this can be by underscore ID. Let's again take in our person ID, and then from before we can copy our bson here to grab this. Okay, so let's copy that in. We have ID is equal to object ID, person ID. That is what we need. And now I'm going to show you how we perform updates. So there is multiple ways to perform updates, but the most common way is to create, I'm going to call this a query object of some sort, or kind of like an update object. And we're going to use some operators here. So the first operator we can use is set. Now what this is going to do is just change the value of a specific field, or sorry, actually this is going to set a new field to be a value of our choice. Now we also can use this to override an existing field, but here I'm going to set kind of a new field on my document to show you how we do that. So in this case, I'm using the operator set. I then need to pass the field that I want to set. So I can do something like new field, and I could give this a value of, let's say, true, because we haven't done any Booleans yet. Okay, so that's set. Now, if this field was something that currently existed, we would override that field. So keep that in mind when you use set. All right, next we're going to have, and this will be inc. So this stands for increment. There's a ton of operators in MongoDB, and we can do age and then 1, and this will increment the age of someone by 1, or whatever the document is that we're modifying. I then can do another operator here, and let's go with something like rename. And let's rename a few fields at once actually here. So what I can do is say rename, and I can do something like first name, and we can rename this field, right? We're not renaming the value, we're renaming the field to be first. And then we can do last underscore name, and we can rename that to be last. Now, that would work similarly here. If I wanted to increment multiple fields, I would just put the field in what I wanted to increment by. If I wanted to set multiple fields, same thing, I'd just list that in here. Okay, now that we have our updates, to update a document, we are going to use the very nicely named function here. So person collection, and then this is going to be dot update underscore 1. We need to pass who we want to update, or what document we want to update. Now we can do that by passing in a query object here that will return to us one object. So I'm going to say ID, and then I'm going to put my underscore ID because I'm updating whatever the person ID is. Then I will go comma, and what I actually want to do for my update. So I'll say all updates like that. Okay, now that we've done that, we can run this code for now and just have a look at what this is going to do. So let's say update person by ID. We need an ID, so let's grab that from Compass here. We can update Tim, so I'll just copy that in. Okay, let's make sure we put that in a string. And let's run this and then have a look at Compass and see if any changes were made. Okay, so I've run the code. I'm not getting any errors here, which is always good news. And if I come back here, notice the age was 21. We should see that go up to 22. And notice the new field has been added, as well as the field names first and last being renamed. Wonderful. So let's just comment this out now, because I'm going to continue writing in here, but I don't want to repeat this. And the next thing I'm going to do is show you how we would, say, unset a field. So actually remove something from the document. So to do that, we can do something like person collection. And again, we can use .update1. So I guess I probably should have copied what I had before, but that's fine. We'll go underscore ID. And then we can pass inside of here the update we want to make. And in this case, I want to unset. So I'm going to use the operator unset. This really kind of just stands for delete. And then I want to remove the new underscore field. But to be able to do this properly, I just need to pass some value. Doesn't really matter the value I pass here. I'm just going to pass an empty string. It's just because we're passing a dictionary in Python, so I can't just have the string there. I have to have the key value pair. So I have unset, colon, and then what do I want to unset? Well, I want to unset the new field. Or yeah, I guess that's it. Unset the new field. So we put our empty string, and then we are good. Let's now run this, and hopefully it should remove that field. Okay, so run the code. Looks like that works successfully. Let's go to Compass. Let's refresh, and notice the field is gone. Okay, that is pretty much all I had to show you for updating a person. Next, what we will have a look at is replacing a document. So we're going to say define replace underscore 1. Again, we need that person ID, so let's take that in. We can copy our bson stuff from up here. All right. And now that we have that, we want to have a document that we're going to replace a document with. Now, you would do this if someone was updating, like, say, all of their contact information or updating, pretty much everything, but they want to keep the same ID, because if you insert a new document, you're going to get a new ID for that no matter what. So in this case, you want to keep the same ID by changing all of the other fields, or while changing all of the other fields. That's why you would perform a replace. So I'll just copy this in because it's not really worth me typing it out, but we'll say new doc is equal to this. This is the new stuff that we want to have. And then here, we're going to say person collection, and we're going to say replace one, and then we're going to pass ID. We're going to pass the underscore ID like that. And then we will have our new document that we want to replace this document with while maintaining the same ID. Okay, so let's now just change our function call to be replace underscore one. Let's run the code. And let's now go back here to Compass. Tim is the one we're going to be replacing, so let's refresh. And notice we have new first name, new last name, age 100, ID stays the same. Wonderful. All right, that is it for updating and replacing documents. Next, we're moving on to deleting. All right, so as I said, we're going to delete documents now. Doing this is fairly straightforward. Let's write a function here. We'll say delete doc by ID. Okay, we'll take in the person underscore ID here, copy our bson. Now, this is as easy as it is. We can write person collection.delete one. This is going to be ID, and then we will pass inside of here underscore ID. So let's try this out. Let's go delete doc by ID. Should have kept my ID, but let's go back to Compass. Let's copy it in. Okay. We have a string, paste, and run, and that should delete just fine. Let's go back here. Should see this document go away now. Refresh, and Tim has been deleted. All right, so that's it for deleting one. Now, if we want to delete many documents, we can use person underscore collection dot, and then rather than delete one, it would be delete many. And just like I showed you the queries before when we were using find, you can use those inside of here to select the documents you want to delete. Of course, same thing with delete one, but yeah, delete many if you want to delete multiple of them. Put in your query. If you just did an empty query like this, then it would delete every single document, which I don't really want to do right now. All right, so as I was saying, we're now going to move on and talk about relationships. So relating documents together and how that works in MongoDB, because it's a little bit different than in a traditional SQL database. Now, when I'm talking about a relationship, it's helpful to have an example. So let's paste in an address here, and let's just do kind of a divide and comments just so we know what we're talking about here. Okay, so we have an address. We might have a person, right? So let's actually say person is equal to, and then let's create this. Now, this is going to have an underscore ID. We'll put in some random value here. This would have an ID as well, just putting these in for example purposes. Okay, so obviously their IDs will be different. And then inside of person, we might have something like, say, the first name, and we can just make that John, and that's all we need for right now. But the idea is that this address may belong to this person. And right now, we don't really have a way of kind of denoting that. And there's a few ways to do this in MongoDB. So the first way to do this is using something called document embeds. Now, this is when you embed a document inside of another document, and that would look something like this. We create a new field here on the person document, and we take our address document here, and we just paste it in. So now we have address, and the address is equal to this document. And this works particularly well when you only have a single piece of information that you need to kind of relate between different documents. In this case, we have an address. We just store the address on the person. All is good. And in fact, this is going to be slightly more efficient than storing them in two separate collections, which is the alternative method. So hopefully that makes a bit of sense, but you can store a document inside of another document. You also can store an array or a list of documents inside of other documents. So if you had multiple addresses, you could embed them inside of the list. So that's fine. However, sometimes we're in a situation where it's not ideal to do that, or this address maybe belongs to multiple people. So if I'm going to be embedding it, I have to embed it in multiple places, and that can kind of complicate things. There's all kinds of pros and cons, which again, I'm gonna get into in a more advanced video. However, let's say we decide we want to store the address and the person in separate collections. We want to organize them in that way for whatever reason. Is there still a way that I can relate this address to this person? Well, yes, there is. And the way we do that is using something called a foreign key. So what I can do here is add a new field to address, and I can do something like owner ID, and I can simply make that equal to the ID of whoever owns this address or whoever this address belongs to, whatever you want to say. So now that I do this, I have a reference from my address to the person that owns the address, and I can use this to perform something called joins, where essentially when I'm searching for a person or I'm searching for an address, I use this field to determine what address belongs to what person. That's hopefully pretty straightforward, but those are the two methods. You have your embedding, and then you have what I'm going to call, I guess, a relationship or, kind of a foreign key in that sense. Anyways, though, I just wanted to quickly go through those. Now let's see how we actually use these different methods to kind of relate objects or documents together. So the first thing we'll do is just using an embed, because that's pretty straightforward. So we can say add address underscore embed here. And we're going to take in a person ID and an address that we want to add for that person. So we need to, of course, grab the ID. So let's take this in here. Okay. Now that we have the ID, we can simply perform an update to the person, and we can add a new field that contains this address. So we're going to say person collection and not insert one, but this will be update one. Okay, update one, ID, and then the update that we want to make here is the following. So as I said before, we can have a list or an array, and we're actually going to use that here to store potentially multiple addresses, because a single person could have multiple addresses, right? So if we want to be flexible, rather than adding a single address, let's add a list of addresses or an array of addresses, as I talked about previously. So I'm going to say add to set is going to be my operation here, because we have the $sign. And then I'm going to say addresses like that, colon, and then address. Now what this says is add this address to the key addresses. And when you put set here, that's indicating that addresses is going to be an array. Now, if addresses does not already exist, it will be created automatically and have a single element. If it does exist, then we'll add another element to it. So append it to the end. There you go. Now we can run this. So let's say add address embed. We need an ID. So let's go back to MongoDB. Let's copy the ID for Sarah. Let's paste Sarah's ID and let's put in the address. Let's run. Okay. And when we run, assuming no errors, we can go back to Compass. We can do a refresh. And then we see we have an array inside of here. We have an object and it contains the address that we just inserted. Okay, so that's method number one. Now method number two is going to be the following, and this is add address underscore relationship. Now really both of these are relationships, but hopefully you get what I mean. Again, we'll take in person ID and address. We're going to paste that like that. And inside of here, we actually need to make a new collection for our addresses, because as I said, we're going to store in a separate collection and then relate them together. So I'm going to say that my address underscore collection is equal to, and then this will be actually our test. Was it test database? No, we had the production database, right? It'll be production dot, and we can just call this address. Okay, so that's our collection. Now that we have that, we can just insert the address into the collection. So we can say address underscore collection, and not update one. We're going to say dot insert underscore one, and then we will just insert the address that's passed. However, before we do that, it's probably a good idea that we add our owner ID field, so we actually have a way to reference who owns the address. And again, we need to make sure that we convert that to an ID first before we do that. So we're going to say address is equal to address.copy, just because I don't want to be mutating the input array here, the input object. So I'm going to make a copy of it, and then I'll say address, and I'll add a field here called owner underscore ID, and this will be equal to the person ID. So now we add that to the address. So when we insert address, we have owner ID, and there you go. That's really all we need. So let's change this now to be relationship. And we'll change from Sarah because they already have an address. We'll go to Jennifer. So let's copy hers and let's paste that. We'll make it the same address because why not? Let's run the code. All right. And let's see what we get here when we go back to Compass and we do a refresh. When we do this, we see we now have a new collection called address. And inside of here, we have the address with the owner ID equal to Sarah. Alright, so I think with that said and me showing you how we perform the different types of relationships, I am going to end the video here. I was going to show you how we perform a join operation, but it's beyond the scope of this tutorial, and I'm going to show it to you in the next one and really give you some more in-depth explanations so that it doesn't feel kind of like, for lack of a better word, half-ass explanation here. Anyways, I hope you guys enjoyed this. I put a lot of work into this video to make sure I could teach you really all of the core functionality of MongoDB as easily as possible. Again, I keep saying it, if you'd like, watch the next video. I will show you some more advanced operations. And again, a massive thank you to MongoDB for sponsoring this video. If you haven't already, you can claim that free credit by using the discount code that is in the description, or I guess the credit code in the description, as well as clicking that link. Thanks to all of you that watched. If you enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in another one.